The squeeze theorem is a theorem that helps you to solve for limits that are indeterminate of a very specific form. So the basic idea behind the squeeze theorem is that if you have a limit and you can't figure out what it is because it's indeterminate in some way, if you know for sure that it's always less than one thing and it's always greater than another thing, if you can figure out those two limits, oftentimes that will help you. So the most common way that you're going to see the squeeze theorem is when you're trying to solve limits that involve a trig function with a variable denominator. So, for example, this is one of the more common examples. So if we wanted to find the limit of that function. So the problem with just trying your direct substitution method here, and if you're unfamiliar with that, you can check out the evaluating limits video, is that this is fine, this would be 0, but the problem here is that when you divide by 0, you're essentially getting some type of infinity, and if you take sine as your inside goes to infinity, you're just constantly oscillating, because remember the sine graph just goes up and down between -1 and 1 forever. So it never stops at any value, it never gives you anything. So this part of the problem is giving you an indeterminate answer. So it doesn't matter that this part is 0. If you multiply times something that's indeterminate, your answer is just indeterminate. So by direct substitution, this is indeterminate. So when you have an indeterminate limit, you always try to simplify. However, if you notice here, there's no simplification that we could actually do algebraically. This is already as simplified as it gets. So we're kind of stuck here. And this is where you're going to use the squeeze theorem. So again, this is the most common form, but occasionally you could just be given an inequality like I'm going to write in a second. So it's usually going to be pretty obvious when you need to use the squeeze theorem. So for a problem like this, what you would need to say is, let me think about what, if anything, in this function we're given. Is anything bounded? So the answer is yes. Sine is definitely bounded. What I mean by that is, if you just took the sine 1 over x part, even though as x goes to 0, you don't know what this is, it's clearly always between 1 and -1. Because if you do the sine of anything, you could only get an answer between -1 and 1, even though in this case you don't know what's in there. So this inequality is definitely just true. Now that doesn't tell you what the limit is yet, but it's a step in the right direction. Because if we know that this is bounded, the next step is, let's try to multiply or divide this whole inequality by something such that we get our whole original problem in the center. So if you notice, the only thing we're missing here is there was an x squared in front. So if we multiply everything by x squared, we'll get this in the center of our inequality. So I'm going to take everything here, I'm going to multiply it by x squared. So I get -x squared, I get our original problem in the center, and I get x squared on the right. So even though I don't know what the limit of this is, I know this function is always in between -x squared and x squared. That's we got just by multiplying an inequality. So I don't know what the limit as x approaches 0 of this is. But if it's always in between these two, if I do the limit as x approaches 0 of them, that will have to give me the limit as x approaches 0 of what I wanted in the first place, the center. So again, if this is always in between -x squared and x squared, then the limit of it as x goes to 0 is greater than or equal to the limit as this as x goes to 0, and it's less than or equal to the limit as x goes to 0 of this. So putting a limit sign in front there does not change anything about the inequality. So this one we can't figure out. But these two on the edge, we certainly can figure out, because this is clearly just 0, and this is 0. So you see here what we've done is we've actually reduced this to a kind of a basic inequality that inadvertently told us the answer. If this limit has to be in between 0 and 0, then it's actually 0. So we're able to say, no, this is not indeterminate. It's actually 0. But you can see this is the only way that you could have done that, because there's no simplification we could have done there. So for the squeeze theorem, like I said, either you will be given an inequality in which you take the limits of the left and the right sides, you'll be able to get the center from that, or you just need to construct one. And when you construct one, the steps are you always start with the trig function, so it'll either be sine or cosine, and it's always in between -1 and 1 for sine or cosine. Next step is multiply by whatever you need to get your original function back in the center. So in this case, we were missing an x squared everywhere, so I multiply everything by x squared. Once you do that, you can take the limit that you want of the left and right, and those will always be easier to evaluate, and it will always give you something that squeezed the center part into just one answer.